This is Mark Isselhart, Maple Specialist with UVM Extension. This slideshow will talk about the fundamentals of filtering pure maple syrup. The first question to ask is, why does maple syrup need to be filtered? And if you've ever made maple syrup before, you'll know that when it comes off the evaporator, it appears a lot like the syrup on the left. Cloudy, has things suspended in it. The syrup on the right is the same syrup, except it's been filtered. And this syrup is ready to put in a retail container or put in a barrel for storage and to be canned later. The other aspect is that it's legally written that syrup has to be clear. And that's one of the 4 standards of grading maple syrup: color, clarity, flavor, and density. So syrup must be filtered and before it can be sold in a retail container. There's also a practical impact of filtering. So again, 2 samples, identical syrup. The sample on the right has been filtered, and you can see it appears quite a bit lighter than the same syrup that's been unfiltered that's on the left. So darker syrup, this might cause you to put it into a different color grade than it ultimately should be. So where do we get to the point where we need to filter it? Well, it starts with maple sap, and sap is a dilute solution of sugar and minerals. The highest concentration of minerals is calcium, although there are other minerals in smaller quantities in sap. So as sap is concentrated into syrup, the sugar obviously becomes concentrated and becomes closer to syrup. The minerals that are in solution in that sap also become concentrated. And they become concentrated to the point where they can no longer be in solution, and they become what's called supersaturated, and they then precipitate out. They form solid particles, and they come out of solution. In sugaring, we talk about 2 kind of forms of these minerals. One is called sugar sand, and that term is used really for the loose material that is stirred up in the syrup, or the gritty material that's floating around in the syrup. And then another term called niter, and that's the minerals that are coated or bonded onto the metal pans. It's also called scale sometimes. So here's a picture of what niter or scale looks like. This is a close-up of the bottom of an evaporator pan. You can see it's very gritty, but it's also platy. It's right on the metal pan itself. Those plates of niter really only reach syrup filters when it actually lifts off, and you can see that some of that niter is already lifted off at the bottom of the pan. There's also what's called sugar sand, or this loose material, and this is the material that is suspended in syrup and has to be filtered out if the syrup is to be clean. The picture on the right shows you one example of what sugar sand can look like. It's almost like a fine powder. But sugar sand can be quite variable in its texture. The picture on the left shows it more like a peanut butter or oily material. This type of sugar sand is really hard to filter. It clogs filters very easily and can be quite frustrating. So if you've ever had a hard time filtering syrup, this might be the culprit. When it's gritty and loose, kind of like the earlier picture I showed you, that sugar sand can actually help with filtering. It can actually help extend the life of filters. Here's just another picture to show you the diversity of forms that sugar sand can take. You can see the color can be quite variable, and the texture can be quite variable too. So again, the picture on the right shows you kind of more like the pasty, oily type form of sugar sand, which can be quite frustrating. The other thing is the size of the particles can be quite variable. Sometimes after filtering, syrup will still have a fine haze, and that's really the result of very, very fine particles making it through the filter medium, and just too fine to be caught by the filter. So there are two broad categories of filtering: gravity type filters and pressure filters. So gravity type filters rely on a fabric type material. The two most common are what are called cone filters and flat filters. They basically use the same material. There's either natural wool, which is traditional material, or there's a synthetic nylon type material. Cone filters are shaped like this, and typically you pour the hot syrup into them and they filter through the bottom. You really should only expect to get about 1 to 3 gallons out of each filter before they become clogged. And then there is a lifespan for these filters. They do tend to wear out. The fibers get worn out as they are used over and over again. Some estimates are you could expect to get 100 gallons through a cone filter, but like everything, it's quite variable. It's hard to really say how much you're going to get out of one cone filter. Flat filters are quite similar. Here's an example of a flat filter placed into a canning unit directly under a draw-off of an evaporator. And you can see the difference is that the flat filter is wider and flat, and so it distributes the syrup over a wider area. It just has less weight driving the syrup down into the filter material. The other category of filters are called pressure filters, and the most common type of pressure filter in sugaring is what's called a plate filter press. So the going clockwise from the top right, you see a small plate filter press, and actually if you go to the left of that, there's another one. Below that is another filter press. The one on the lower right is what's called a canister filter. All of these work through, as you might imagine, forcing syrup, pressurized syrup going through a filter medium. The example on the upper left is a hand filter press, and all the other ones rely on an electric pump. So getting back to gravity filtering, the keys to gravity filtering include using a pre-filter material, and this is a slightly looser, slightly less fine filter material that's thin and gets put inside the main fabric filter. The design of these is really to catch big stuff, and that allows the main filter not to get clogged too quickly. The other key thing is syrup temperature. Syrup really needs to be hot when it's going through these filters. Hot enough so that it will go through quickly, but not so hot that you're concentrating your syrup too high and going beyond the density of syrup. Going along with that, syrup density really must be correct. There are two things that could happen. If you had syrup that was too dilute, or not dense enough to be called pure maple syrup, it might go through the filter really easily. But the problem is then after it's been filtered, you would need to boil it again to bring it up to correct density. Anytime you bring syrup up to the boiling point, or even below the boiling point, anytime you reheat syrup, you have the potential to form more niter and more sugar sand, and it's an issue. So you might end up having to filter twice if you have underdense syrup. The issue of overdense syrup is that the material is so viscous that it just doesn't like to go through the filter as easily. So take care in getting the density just right and making sure it's hot, maintain its temperature, and you'll have the best bet of getting your syrup going through. Here's a little close-up of what the pre-filter looks like. This is a cone-type pre-filter. It's sewn in the same shape as the cone filter. Sugar makers often use multiple pre-filters, so you'll have a stack of maybe 3 or 4 of these pre-filters tucked one on top of each other inside the main cone filter. Then as a pre-filter becomes clogged, you can transfer the syrup that's left into the next pre-filter and then clean the pre-filter that has been clogged. Here's an example of what that cone filter looks like when it's actually working. On the left, you see hot syrup going down into the cone filter, and then on the picture on the right shows sort of all that syrup being focused in that one point, the lowest point on the filter, and it seeping out through the bottom. And again, here's a picture of a flat filter. It's being suspended not just by those clips, but there's a mesh basket basically that supports the flat filter. Typically, producers with very small batches of syrup will be using a cone filter, and some people who have a little bit larger production might go to a flat filter, because if your draw-off volume is big enough, you can spread it over a larger area and filter more. But for really small batches of syrup, cone filter is probably the best bet. Here's just a sort of a stylized graph showing you how time, and you could even put this as temperature, as time goes on, the syrup filtered through a given filter drops dramatically. And the same could be said as syrup cools. The amount of syrup filtered through a filter really drops dramatically as that syrup cools. So the key is to know the limitations, how much you could possibly get through a gravity filter. Make sure you keep your syrup hot. And people who have had really good luck using cone filters have either a commercially made or a homemade container to hold the syrup and the filter in one place with a cover. Again, trying best to retain the heat, keep the filter warm and keep the syrup warm, and to maximize how much syrup you can filter. The other thing that's important to remember is that you need to treat these fabric filters very gently. You really only want to clean with hot water, never any detergents or anything which could impart an off flavor on your syrup. You also don't want to wring out or twist those fabric filters. This can cause tearing or ripping in some of the fibers of the fabric, and as you might imagine, they just allow the unfiltered syrup to kind of bypass the intact filter, and you'll end up with some cloudy syrup. The other thing that's important to remember after you're done with your filters and you've rinsed them very well with clean hot water, don't store it wet. You want to make sure those filters become totally dry before putting them away. What can happen is you can have mold form in the filter, and it will then impart an off flavor to your syrup the next time you use it. So the next big category of filters for maple syrup are what are called pressure filters. There are two types, filter presses and canister filters, like we said earlier. They both rely on pumps to force unfiltered syrup through filter aid, also called diatomaceous earth. And the diatomaceous earth is kept in place with a filter media, which is also known as filter papers. They tend to become necessary as sugaring operations grow in size. Probably the biggest thing that pressure filters have above gravity filters is just the rate, the efficiency you get when you have a pump. You can filter a lot more syrup in a shorter amount of time. But like other filters, they have a limited capacity, and they do need to be cleaned when it's required. And the other thing is that there is a significant cost to purchasing these pieces of equipment. That's balanced against the time savings. So it's a choice you have to make depending on the size of your operation and a couple other factors. So the most important thing about a pressure filter is really the filter aid. Diatomaceous earth is the material. It's the skeletal remains of very simple marine organisms. You can see these microscopic pictures of this material on the right. They are they settle into huge deposits, and they become mined. They're mostly made of silica, and the benefit of this material is the fact that it's got a huge amount of complexity. The particles, you can see all the different little holes and shapes. those end up making the biggest difference as far as filtering. The other fact is that this material is rigid in that it doesn't compress too much, and it's inert. It doesn't react with the stuff being filtered, in this case, maple syrup. Diatomaceous earth is used in lots of industries, in other industries, including food, because of these qualities and because it is such a good material to filter through. Diatomaceous earth is also used in other types of filtering, things that don't involve food. So, for instance, pool filters often use diatomaceous earth. So it's really important that you only purchase food-grade material, and to make sure you have the right material, it's important to buy it directly from a maple equipment dealer. So even though it might be cheaper to buy a pool filter, diatomaceous earth, don't do it. Make sure you buy the correct stuff from a maple dealer. It's also important to think about how you're handling this DE. It comes in large bags typically, and if they become moist, it can have an impact on how well the filter aid works. It can even impart an off flavor to your syrup as it's filtering. So make sure to keep the DE dry and not moldy. So this slide might be a little bit confusing, but bear with me. We'll see if we can make it make sense. All the way on the left, what you have is basically a zoomed in image, if you will, of the edge of a piece of paper. In this case, it would be a piece of filter paper. So imagine you're looking at the edge of a piece of paper. And the blue lines, the blue arrows, represent the flow of maple syrup through that paper. So it has no problem getting through that paper when it's pressurized. To the right of that, you see the same thing, piece of paper, filter paper, with the flow of syrup going through, except now we've added some of that filter aid. Some of that DE is packed up against that filter paper. And you can see the filter aid won't go through. This helps explain why when you're adding DE or filter aid to your hot syrup and pumping it through a filter press, people might think that you're making an addition, you're adding something to syrup, but it won't fit through. The particles are too big to fit through the pores of the filter paper, and they all get caught by that paper. Looking to the right, you see that same setup, the edge of the filter paper, the accumulation of filter aid, and then you see these particles, the sugar sand, start to accumulate. It starts to get trapped by that, what we call a cake of filter aid. You can see the DE or filter aid is catching that material. And then the next image to the right, you see that you've had some sugar sand caught, but you've also added more filter aid. And so no one surface of that filter setup gets clogged as you're constantly adding some more and more DE. So the canister filter is another type of pressure filter. It works in a similar way, except instead of papers, it uses a cloth that gets wrapped around a cylinder. The lower right-hand corner of this picture on the right, you see a metal cylinder with a white fabric cloth being wrapped around it. That's the filter media. So instead of paper, it's a fabric. And what happens is the DE is added to the outside of that fabric, and the unfiltered syrup gets forced through that, which then ends up having filtered syrup on the inside. You need a pump. Both types, the plate filter press or the canister filter press, relies on a pump to pressurize that unfiltered syrup. You can imagine that unfiltered syrup really doesn't want to go through a fine filter, and it'll just sit there unless you have some pressure behind it. The canister filters are made in a couple of different sizes, and the bigger the size, the more surface area, and the more capacity to filter. The range, you can see the smaller ones, maybe 15 to 30 gallons per batch before you have to break it down. The larger one, maybe 40 to 60 gallons. But I'll caution that it's really a range. It's really hard to predict on any given day how much you'll get through. But typically the minimum amount is reasonable. The canister filters have a less surface area than most plate filter presses, so the capacity is a little bit lower, but they also have fewer parts, and certainly some producers like using them. Probably the most common type of pressure filter in the sugaring industry is what's called a filter press. It uses a combination of hollow plates and backer plates, as well as filter paper and a filter aid, like we mentioned before. It's important to realize that the filter press, depending on the size, they all work the same in that every plate fills simultaneously from the bottom to the top. So the whole thing gets pumped into the press as the press fills up. When it finally does completely fill with syrup, that's when the filtering takes place. Filter presses are used in lots of other industries, and they are certainly effective. So filter press capacity, the amount of syrup you can filter in a given setup of a filter press, is really dictated by the total volume of your press. So the number of cake plates all added up, the volume of those cake plates added up, and also by the quality of the syrup. So if the syrup is easy to filter, you'll be able to get more through your press. If the syrup is difficult to filter, you'll get less so. You can maximize the capacity of your press by utilizing all the available volume. In other words, by filling those cake plates with as much DE and filtered out sugar sand as possible, you'll be able to extend the life of a given filter press setup and filter more syrup. If you only put a little bit of DE in, you likely will not be maximizing the capacity of your press. The other thing you should know is that late season syrup is really the stuff that can be very difficult to filter. It tends to be a little bit more paste-like, a little oily, and it just doesn't want to filter well. And there is certainly a time when syrup just won't filter through. Like I said before, there are lots of different sizes of filter presses. The smaller the press, the smaller the capacity it has to filter. The filter press on the lower right is a 5-inch hand-operated press. Above that, there's a 7-inch press. On the left, I'm holding one that is actually 24 inches, so it's quite large. This one wasn't designed for the production of maple syrup, but it was used for that purpose. It's also important to talk about the pumps used in filter presses. So the pump on the right is what's called a gear pump. It's a relatively simple device. It has 2 intermeshing gears, and as they spin, the syrup is sucked in on one side and pushed out under pressure on the other. They are less expensive than some other pumps. They only have one speed, so it's on or off basically. They require a motor and a belt. The other issue is that they are largely made of brass or bronze alloy, which even in a low lead construction can potentially introduce some lead to your syrup. So it's really important if you have one of these pumps in your operation to check for lead in your syrup when it's all done, and just be aware that this is a material that really isn't used in food production and should be phased out. The pump on the left is what's called a diaphragm pump. They typically are a little more expensive. They use a flexible diaphragm and compressed air to push the syrup through. The compressed air never touches the syrup itself. It's on the other side of the diaphragm. They are, like I said, more expensive. One positive is that they are variable speed, so you can slow down the pressure or the speed at which that pump goes. The other benefit is that they're made of food-grade materials. I should say that there are gear-type pumps that are made exclusively of stainless steel material, so producers who really like the gear-type setup should look into sourcing a stainless steel version. So now I want to walk you through the basics of setting up a filter press. The plates you see in front here, the one on the left is what's called a cake plate. That's where all the filtering really takes place. And the plate on the right is a waffle plate. It's also called a backer plate. That basically supports the filter paper under pressure, so it won't burst. If you look down at the plate on the left, the cake plate, you see at the bottom there are two holes. The hole on the right of the cake plate is where the unfiltered syrup gets pumped through, and it's a little hard to see, but there's a little notch cut out of that right above the hole. That's where all that unfiltered syrup gets pushed into the cavity created by the cake plate. There's no place, once it all fills up, all those plates fill up at once, there's no place for that filter to go, or that syrup to go to relieve the pressure unless it goes through the filter paper and all the DE. When it does go through, it goes through the tiny holes. If you look at the waffle plate on the right, look at the lower left corner on that waffle plate. See those tiny little holes that are milled in to the just above the hole on the left? That's where all the filtered syrup goes through. So, like I said before, all the syrup floods into all the cake plates at once, and then it all starts to filter through all those tiny holes on the left. So if we were setting it up, the first plate is typically a backer plate or a waffle plate, and there's usually some arms to hold the various plates together. So first you need to put on a fresh piece of paper. That's what this looks like, and you can see there are holes in the filter paper corresponding to the holes for where the unfiltered syrup comes in and the filtered syrup leaves the press. Then you put on a cake plate. So you've got a backer plate, piece of filter paper, and then a cake plate. You need another piece of filter paper. After that, and then you add a backer plate. This gets repeated over and over again, but this is basically the whole thing for a filter press. You've got backer plates and then a cake plate in between. The hot syrup, unfiltered syrup, floods into that cavity and gets coated with DE and then gets filtered out. From here, you obviously continue to build the this manufacturer engineered it so that if you put your cake plate on backwards, it wouldn't look correct. It would be tilted, so that you would just have to turn the cake plate around to make sure it was set up correctly. Different manufacturers have different ways of indicating to the producer that the plates have not been installed correctly. It could be the arms holding the plates are at different levels, like this one, or it could be a line milled into each plate that when they're all lined up, you know you have a correct setup. If one piece of the line is out of place, then you know that one of the plates is turned around. You want to make sure that the filter papers have not fallen down. This manufacturer has a metal rod going underneath all the plates, and you can check to see that they're all sitting properly and they're not blocking the hole, basically, of the inlet or the outlet. You also want to look down through both the inlet and outlet to make sure there's nothing obstructing it. If you have an accumulation of niter, and that could cause a problem for sure, or if a paper has slid down somehow, that could be a problem as well. The last plate's always another backer plate, but it typically is a little thicker, and then you tighten it down with these wing nuts and washers. There are lots of different manufacturers of filter presses. This is just one, but they all typically have the same type of setup. So now we're in a situation where the press is totally set up, the plates are correct, the filter papers are in between all the plates, and we're ready to start filtering. But we need a way to introduce the filter aid, or DE, into the press. We do that by something called pre-coating the filter press. We want to get from a situation where we're here, where there's just syrup would be going through the paper, to something more like this, where there's DE or filter aid pressed up against those filter papers, and the DE is actually really doing the filtering. So to pre-coat, you want to take some of the filter aid or DE that you're going to use, mix it up with a few gallons of hot syrup, and you're basically going to pump that through the press to make sure you're getting a good coating of DE before you really start filtering. The exact amount of DE needed and the amount of gallons of syrup you're going to need is really going to depend on the size of your press, and I'll point you in the right direction about how to estimate how much of each you're going to need at the end. You really want to make sure that the pre-coat will cover all the filter papers, and it really helps to prevent early clogging of your setup. It's also a chance to check for the clarity of syrup, so to make sure that the press is working correctly before you start putting it into a canner or into a bulk container. It's also really important not to interrupt this stage. In other words, don't start with the pre-coating process and then stop it halfway through, turn it back on again, and expect it to really work the same. You really want to get a nice even coating of that DE across the entire surface inside the press. You can use water or syrup for this pre-coating process. If you do use water and you have a really small press, you do want to make sure that you're not diluting that syrup at all. So I can show you a slide of what this kind of looks like. It's a little confusing. There's a lot to see here. I will point out that a copy of this diagram is available, and I'll show you where to find it in just a minute. Basically, what we're talking about here is taking a little bit of unfiltered syrup, stirring it up with some of your DE and pumping it through the press. But then instead of going into a barrel or a canner, circulating it back into that bucket that you pulled the unfiltered syrup out of. Again, this gives you a chance to look at syrup clarity, make sure everything's working properly before you connect to your large batch of syrup. And really, when you do go to do your whole batch of syrup, really what you're doing is you're just connecting to a large container, either your finishing pan or a draw-off container, and then you're connecting it in the outlet into a bulk container or a canning unit. Feel free to review this diagram to understand the details. So when the pump is actually running and its syrup is being forced through that filter medium and the DE, you're going to get a little bit of weeping or a little bit of syrup escaping from between the plates. That's normal. What's not normal is when there's a lot of syrup squirting out. Then you know you have a problem. So the way to anticipate or to shut down before you have a problem, you want to have an eye on the pressure gauge. So filter presses will come with a pressure gauge. Generally speaking, when you're running the press, there won't be hardly any pressure developed in that press at all. When you start to see pressure building, what that means is that press, that setup is starting to clog. And you really need to be careful and keep an eye on it, not ignore it anymore. If you don't do this and you ignore it, the pressure will go so high that the papers will tear. It's also called blowing a paper, and that's when you'd have a problem. You'd have diatomaceous earth and unfiltered syrup going into whatever container you were filtering into. So you really want to avoid that from happening. You can find more details about setting up a plate filter press, including recommendations about how much DE you need for a given batch of syrup. In this document, we have a digital copy on our website. If you just check out the UVM extension Maple page, you'll find it there. Thanks for listening to the fundamentals of filtering pure maple syrup. I'm Mark Isselhart, Maple Extension Specialist with UVM Extension.